Technology is changing how we interact with everything and everybody around us. We will soon have more than 50 billion smart devices. That's 4 devices for every one of us. But what does smart mean? How can a device be smart? A smart device can operate on its own. It can connect to the internet. It can tap into sensors, gathering data about our activities, our locations, our surroundings. What is one example of these smart devices? Well, take a look at the device in your hand, in your pocket, in your purse. These devices are powered by lithium-ion-based batteries. However, these batteries have limited lifetime before recharging, as we all know. But what is draining the batteries of these smart devices? And could we possibly extend the battery lifetime of the smartphone and of other more important smart devices? Because, let's face it, these smart devices can improve the quality of life if properly used. Smart devices are transforming our lives. Gadgets from thermostats to ovens have become smarter, using temperature sensors to set the ideal temperature in a room, or cook a pizza just the way you like it, even if you're not around. Smart devices can even remotely collect a wide range of health data, such as blood pressure, blood sugar, or the heart rate, saving lives in the process. Smart devices aim at empowering us, at freeing us, and at enhancing our life experiences. But yet, we are still governed by the tyranny of wires. So there is still a need for wires that recharge these devices, but limit our mobility. So what can we do? These smart devices have applications that run on them, and these applications have to continuously tap to sensors, such as the GPS, in order to collect information and benefit us. This is one major reason behind the high energy consumption of smart devices. Add to that, battery technology has not kept up with the rapid growth of smart devices. As for sensors, they are getting cheaper, smaller in size, and more powerful, draining the batteries even more. What a vicious cycle, right? Smart devices, sensors, wires, applications, it all boils down to energy. One day, I performed an experiment on my smartphone to get more insight to what extent can these applications drain the battery of my smartphone. It turns out that the battery of my smartphone can reach up to 50 hours when all applications and sensors are turned off. But when I turned on just one fitness tracker application, it decreased to 20 hours. So I enrolled into an accelerated PhD program at AUB that speaks to my passion for smart devices and further investigates how to reduce energy consumption in these smart devices. Smart devices have the power to give us data that is very important. But one solution in order to help reduce energy consumption is to stop applications from continuously tapping into sensors through forcing a lower sampling frequency into these sensors. But imagine having an application, a fall detection application, that tracks your elderly family member. You want this application to be as accurate and responsive as possible. On the other hand, randomly lowering the sampling frequency will cause a delay in detecting the critical event and will give us a less accurate result. So a critical event in this case can be that your elderly family member needs caregiving, and this is very critical. Now, the higher the energy, the higher the performance, but the shorter the battery lifetime. So there is a trade-off, and I had to strike a balance. Ideally speaking, we do not want to use these sensors or devices until the exact moment of a state change, during which there is an important event that's happening and should be detected. I use dynamic programming in order to design a dynamic and optimized smart dynamic sensing schedule that finds the suitable time instance at which these devices should be ready for data collection based on the user behavior. So my system triggers the sensors only at necessary time instance rather than continuously collecting data. Better yet, I use optimization techniques in order to help applications choose what sensors to trigger at runtime. Recently, users are carrying more smart devices besides the smartphone. In addition, we are surrounded by smart devices in our houses and in our workplaces. There are different multiple alternatives of these sensors that could be used by the smart devices. And if it wasn't for my system, applications won't be aware of these different sensor choices. Energy is particularly consumed when several energy-hungry applications run continuously, simultaneously, and without coordination, trying to greedily collect as much data as possible about us users, just as like these lemurs are trying to get their food, without any coordination in between. So I worked on finding the synergy among these running applications and exploiting the advantage of having some common sensors in between the requested data. So I built a context-aware framework that coordinates the work of all these applications, collecting the requested and the necessary data while at the same time preserving the precious energy. My framework can save up to 70% of energy when compared to continuous sensing, thus prolonging the battery lifetime and saving users from the hassle of finding available outlets or stocking up on portable power banks. My framework has to mainly adopted by the big players of the smart devices. But as users, we can all help implement such strategies. So we frequently download applications that make our lives easier. Downloading an app is as simple as a click in which you agree on the terms. But have you really read the terms? So embedded in these terms, most of these applications state that they will use our sensors frequently, if not continuously. So I know no technology is perfect, but let's build intelligent systems and softwares and devices that make everybody's lives easier. Because, let's face it, these smart devices can improve the quality of life, but if properly used. Thank you.